So kind of a little bonus for us, a couple extra problems. Graph where y equals 3 secant of 1/2 x. Now, if you wanted to, you could rewrite that as 3 over the cosine of 1/2 x. And so that's going to equal 0 in the denominator. Basically, you're going to find your vertical asymptotes when 1/2 x equals 2n plus 1 over 2 times pi, basically odd multiples of pi over 2. I'm going to solve this by getting rid of the denominators first. And really, that's all I have to do to solve it, is just to multiply both sides by 2. That's going to leave me with x equals 2n plus 1 times pi. So that's just your odd multiples of pi. We can see that by checking out what happens to this little slate of points. These values of n give me x is 5 pi, 3 pi, pi, negative pi, and negative 5 pi. No, negative 3 pi. There we go. So those are going to be your vertical asymptotes. Now, when you're drawing this, I would label your axes so that it's convenient for you. Instead of units of -1 and things like that, 1, 2, 3, label it in units of pi. Pi, 3 pi, 5 pi, etc. It's going to make your life easier, more user-friendly. Now these are going to be my vertical asymptotes. So let me draw in some lines here. I'll do one more here, -3 pi. And then I'm just going to put little dash lines because these are asymptotes. They're not actually part of the graph. And so on. Now I only need 2 periods of this, so I'll just draw a couple more of these. I'm not going to draw it for the whole graph. So and this should be enough. The only thing left I got to do is figure out the exact shape of these things. Now, that doesn't apply here. We're looking at this graph. I know it's going to go down to a minimum of 3 and up to a maximum of -3. I just got to figure out where that shape starts and where that ends. You could do that by graphing this on your graphing calculator. So that would look like this. And let me just take a quick peek at my window. -4 to 4, it might be helpful to have this in units of pi. So I'll go from -3 pi to 3 pi should be good enough. I should see the pattern by then. 3 pi. And a scale this time of pi. That way it puts tick marks at it someplace convenient. And I'm happy with things on the y-axis, so I'm just going to hit the graph key, and there you go. So you've got the correct shape. The thing that you should notice the most is that it comes down to a minimum of -3 and up, excuse me, minimum of 3 and a maximum of -3. So let me note those as I graph this. So here at 3, here at -3, and then 3 and -3. Notice it alternates from there. And just play this game of drawing that shape in here, and here, here, and here. So that's one period, that's the second period. Done. Done. Let's look at the next one. Comments or thoughts on this one? Doing okay there? So the next one is going to look, let's see, where was the next one? 1/2 tangent of 3x. That's going to equal 1/2 times the sine of 3x over the cosine of 3x. This one's going to be a little bit more troublesome. Again, you're going to look for where the vertical asymptotes are by finding where cosine of 3x equals 0 when this equals 2n plus 1 over 2 times pi. Now solving this for some of you might be a little bit of a pain because you got to divide by 3 and then you got a fraction divided by 3. A lot of you might not be in your comfort zone there. So let me suggest something different as opposed to dividing by 3. How about if we multiply by the reciprocal? How about if I multiply by 1/3 on both of those? And that way you don't have to worry about that fraction within a fraction. On the left-hand side, that cancels. On the right-hand side, 1 times the numerator, well, it's still the numerator, 2n plus 1. 3 times 2, let me get out my graphing calculator there for a second. There we go. 6. Now, not as cool or as friendly of an expression as we've had elsewhere, but still workable. So let's do n, and I'm going to pick the traditional slate of points that I've been using for all these kinds of problems, and that is -2 to 2. If x equals 2, then I'll get 5 pi over 6. 5 pi over 6. If x equals 1, I get 3 pi over 6. Pi over 6. Let's see. Negative pi over 6. And negative 3 pi over 6. So, now it's true that these reduce to pi over 2 and negative pi over 2 respectively, but you know, for my convenience, I'm just going to leave them all in units of pi over 6, and that's the way I'm going to label my x-axis, is in units of pi over 6. So let's do that here. I'll call this one pi over 6. This will be 2 pi over 6, and then this will be 3 pi over 6, 4 pi over 6, and 5 pi over 6. Negative pi over 6, negative 2 pi over 6, negative 3 pi over 6, and so on. But that's enough to give me the points that I need. Let's draw on some asymptotes. So I'll draw on some asymptotes here. If you wanted to, you could graph this on your graphing calculator directly, just to take kind of a look at it and see the general shape of the function in each of these little intervals between vertical asymptotes. In the interest of time, I'm not going to do all that. I'm just going to tell you that that shape is going to be the increasing shape that we're accustomed to for the graph of the tangent, since it hasn't been flipped. It's going to look kind of like this. It's going to go through the x-axis right between your vertical asymptotes. So it should look roughly like that. And this is more or less all that I'm really expecting when you graph this for me on an exam. And I don't care if these are reduced or not. I really don't. I think it's actually easier. You can kind of see the pattern if you don't reduce them, would be my suggestion. When you're graphing this on the graphing calculator, let x scale equal pi over 6. That'll be helpful for you there. Sweet. All right, let's take a break.